Following video is part of my practical TypeScript course. And if you wish to enroll in the full course, please navigate to codingaddict.io. Again, the URL is codingaddict.io, or you can utilize the link provided in the description. And up next, let's explore the typeguard options available in TypeScript. Basically, my goal was to gather all of our options in one place. And since we already discussed most of them throughout the course, this section will primarily feature challenges. So if you're interested, read the steps and attempt to complete the challenge before watching the video. Also, for some challenges, I already provided starter code, so we can spend more time on the typeguard concepts. And we're going to start with the good old Typeof typeguard, and this is going to be our starter code, where we have a type. It's either string, number, or Boolean. We assign it to a variable, and then we just invoke math.random. And then depending on the random value, if it's less than 0.33, then the value is going to be hello. If it's bigger than 0.33 but less than 0.66, then it's going to be a number. And if it's actually bigger than 0.66, then it will be a Boolean. And our goal is to set up a function. In my case, I'm going to call this check value that takes in one parameter value, and the type will be this value type. And inside of the function, effectively, we want to check for all of these conditions for the string, number, and Boolean. And based on that, we want to do something. Again, it doesn't really matter what we do as far as the functionality, but we do want to set up those type guards correctly. So let me just take the starter code just so we can spend more time on the actual function. Let me set it up here in tutorial, and let me start working on the function. So we want to go here with function, then check value. This will be looking for the value parameter, and I'll right away set it equal to a value type. Now this function is not going to return anything, at least in my setup. And then let's just set up those type guards. And remember, one of the most straightforward type guards we have is Typeof. And then we have a bunch of possible values. So if I go here with if, then Typeof, I'm looking for my parameter, and I set it equal to, and in here we should at least get a list. Now the reason why we don't have the list is because I have 3 equal signs over here. So we have this big int, Boolean function, and you can read the rest. So let's start with the string one over here. And I guess since people are tired with the uppercase, why don't we go with log and value 2. And let's try the lowercase somewhere to lowercase. Okay, good. Let's return. So we want to set up the return here. Then let's check for the number. And if we bypass both of these conditions, then logic tells us that the value is going to be Boolean. So I guess, you know what? In order to speed this up, I'll just copy and paste. In this case, I'm not looking for string. We're looking for number, and then we want to go with 2 and fixed. And let's pass in 2. Again, we want to return, and at this point, it is a Boolean. So let's go here with log, and let's just log the value. So let's access the value, and let's invoke the function. So let's go with check value and pass in the value. Now let me navigate to browser. Notice at this point it's a number, then I have hello, and at this point it's a Boolean. And with this in place, we can move on to the next type guard. All right, and the next type guard we're going to discuss is going to be equality narrowing. Now, don't be scared of the fancy name. Essentially, it's just a narrowing which occurs when we use equality checks. Now, I think we'll right away also go with the check for property type guard, because effectively we'll have the same starting code. So we have these two types. One is dog, one is cat. And in here we have the type property, which references the actual type. And also we have the name as well as the method, which is unique to that specific type. And essentially, our goal is to come up with a function which is going to check for that specific type. And if it's a dog, then we bark. And if it's a cat, then we meow. And like I mentioned before, we'll pretty much work on both of the challenges since the starting code is the same. And we just have multiple options how we can narrow down one of the types. So in tutorial, I want to grab this code. Notice how we're using over here the union as well. So now we have this animal, which could be a dog or a cat. So now let's set up our function, which makes the sound. So make sound function. We're going to go with animal. So that is going to be our parameter. And that one will be equal to our type animal. And here, let's go with animal and which property is unique. Well, that will be the type one, correct? So we can just say, well, if animal type is equal to, in our case, dog, well, what do we want to do? We're going to go with animal and bark because we know that it's a dog. Now, if it's not the case, we already know that we have animal and our other option essentially is to meow. So if we go over here and just invoke the function, depending on what we're going to pass in, that's what we're going to get in the console. Now, at the moment, again, there's no functionality over here. Hopefully, it's clear that effectively we're just narrowing down the types. So this is one option we have. Also, we can check for property. And how does that look like? Well, we can go here with function, then make sound, same deal. Animal is equal to our animal type. And then inside of the function, we want to set up if, and now we're looking for a specific property in the type. Now, in our case, which one is the specific one? Well, we can actually check for method. We can take a look whether bark exists. If it is an animal, then we know that it's a dog. If not, then in our case, we know that it's a cat. So we're going to go with if and then bark in. So this is a keyword we want to use in the animal. Well, if it's the case, let's go with animal bark. And if not, then we know that it's a cat. So we can run the other method. Let's go with meow and let's invoke it. So effectively, when we have such setup, these are the options we have. Either we can check for property or a method, or if we have a property which has that unique value, for example, in this case, it's a type one, well, then we can also use the equality checks. All right, and up next we have Truthy or falsy guard, and it's as straightforward as the name suggests. Essentially, in here, where you just want to check for truthy or falsy value in the condition, and depending on the result, just set up the functionality. And as far as the challenge, we want to create a function. In my case, I'm going to call this print length. We're going to be looking for a string parameter. As far as the type, we're going to use the union type. So either it's going to be string, null, or undefined. And then if it's truthy, if it's a string, then we just want to log string dot length. If not, then we'll just say that no string was provided. And then we'll just test with few values. So here in the tutorial, we want to go with function print length. Let's look for string. I'm going to go with str. And then as far as the type, either it's going to be a string, either it will be null, or we're going to go here with undefined. And if we want to check for a valid string, we simply want to set up the if block and then pass in the str. So if it's truthy, if there's value in a string, then we'll end up in this if block. And as far as the logic, we're going to go with str and then length. So at this point, we know that it's a string. Now, if it's not the case, I'm just going to go with log and let's just go with something generic. No string provided, even though as I'm looking at it, I mean, we're also going to end up here if there's no value in the string. So technically it's not 100% correct, but let's just go with this one for now. Again, our main purpose was to set up the functionality inside of the function. So let's go with print length. Let's go with hello over here. Then let's pass in the empty string. Then we're going to go here with null. And after that, let's pass in pretty much nothing. Let's at least try to do that. Now we're not going to be able to, since Typescript is going to complain, but let's just pass it in just for our reference. So let's say if we don't provide anything. And also at the very end, let's go with print length and set up the undefined. Now let's navigate to console and essentially notice if we provide a valid string, yep, the result is 4. So we get back this length. And if not, then we just have a list of no string provided. Again, not 100% correct technically in here. It is a string, but it's an empty one. But again, these are just minor details. The main goal of this video was to showcase the Truthy or falsy type guard in Typescript. All right, and up next we have Instanceof type guard, which is a way in Typescript to check the specific class or constructor function of an object at runtime. And this is something we actually covered very, very recently when we talked about type unknown. So therefore, in this case, again, we'll have two examples. We will go back to try and catch. So we'll reiterate pretty much everything we learned in the type unknown video, and also we'll work on another example where we'll check for the date. So first, let's just reiterate that if we have try and catch, this error is unknown. So even though we have over here for sure throw new error, and if I pass in the message, Typescript will complain if we'll just go with error.message. Because there's also a possibility for different type of error. Essentially, we might have an error which is not the instance of the error class. So therefore, if we do want to access the message, first we want to go with error and then instance of, and we're looking for our error class. So if it's the instance, yes, then we know that there is that message. If not, well, then we simply want to log something, some kind of hard-coded message. So let's go here with log, and then let's provide some kind of string. And we're looking for error, object, and now we just want to render, I guess, the error message. So error, that message. So now we can access it. If not, well, then let's simply log something else. We'll just go with unknown error. Error and ... Again, if we navigate to the browser, if everything is correct, we should have this one over here. Why? Well, because at the moment in try block, I have try new error. Now, if I'm going to comment this one out or simply type above and say throw and some error, now I should have unknown error in the console. So again, this is something we covered pretty much a few videos ago. Now, also, we can use such setup to check for date. So we can check whether the input we're passing in is a string or it's actually the instance of the date object. So let's set up our function. We're going to go with check input. And in here, the variable name is going to be input, basically the parameter name. And then either it's going to be date or it's going to be a string. Now, from this function, we want to return a string. And now we want to check whether the input is the instance of the date object. If it's the case, then we want to turn it into a string. Now, if it's not the case, if it's simply a string, then we want to return the input. So let's go with input instance of, then data object here, And then let's use input. Since this is a date right now, we have access to all of these methods. We're looking for get full year. Let's invoke this one, and we want to turn it into a string. So notice, if I just return this one, TypeScript immediately complains because this will be a number, but we said that we want to return a string. So let's invoke this to string. So now TypeScript is not complaining. And if it's not the case, if it's not the instance of the date, well, then I don't need to do these acrobatics. I can simply return the input. So now let's construct two variables. We're going to go check input. In here, let's just pass in new date. And also, we're going to go with some random value as well. Random, and we'll set it equal to check input. And let's just pass in some kind of string. So 2020, the best year ever. Of course, in the air quotes. And let's pass in some random date. Then let's log both of these values. We're going to go over here with year and random. I'm not even sure whether we are really interested in the console, but let's just log it and notice essentially both of them are strings. And again, the instance of TypeGuard is a nifty way for us to check in TypeScript whether the object is an instance of a class or created by the constructor function. If it's the case, it's going to return true. If not, it's going to return false. All right, and up next, let's discuss type predicate function, which is a special kind of function that not only returns true or false, but also we can narrow down the type. And again, this should be a refresher because we did discuss type predicate previously. As far as the star code, let's just grab this one and then we'll go over the challenge. So here in tutorial, I have two types. I have the student one as well as the user. Notice this property is the same. It's a string. And the only difference, well, they have different methods. So one is study and the other one is login. Then I use the type union to create type person, which can be either the student or the user. And then again, I go with my math.random. If it's bigger than 0.5, then I'll return 1. If not, well, then I'll return another one. So either this is going to be a student or a user. And effectively, what we want to do is set up our type predicate function where not only we check for specific type, but we also want to help TypeScript by narrowing down the type. And in my case, I'm going to show you two options, how we can check for specific type, but feel free to use whichever makes the most sense to you. And then after that, we want to use if else, essentially run our type predicate. And if it's true, we want to invoke one of the methods. So let's say in my case, I'm going to be checking for student. If not, then I'm going to invoke login, which is for the user. So right after the person, I'm going to go with function is student. At least in my case, I'm going to be checking for student. Again, this is totally up to you. You can check for the user as well. Now, I'm going to be expecting a person, which again can be either of them. For now, I'm not going to set up the return type. And as far as our options, well, we can use the in operator, something we talked about literally a few videos ago, where again, we're looking for something unique. In this case, either it's going to be study or a login. And we just go with the method name, then in, and then the person, since that's our parameter. Or we can also use the type assertion, where we assert that person is going to be a student. Then we invoke the study method, and then we check whether it's defined or not. So again, this part is totally up to you. For now, again, we don't have any returns. I just want to showcase that if we go here with return and then study, again, our method in person, this will return either true or false. So either this method is in the type or not. Now, if it's the case, then we want to go with person is the student, correct? because at that point, TypeScript knows for sure that the instance is the type of student. And if that's the case, then we can use the study method. Now, alternatively, we can use this approach where we go to return, then person, and we assert that it's a student. Now, what is the method student has? It has the study one. But again, just because we're asserting doesn't magically make this person to be a student. And therefore, in here, we still check. We say, okay, we assert that person is a student. We know that there is a study property, but it also can be undefined. So it's only a student if it's not undefined, like so. So those are the two options you can use over here. And now let's set up the if block. Let's say, well, if it's a student, then let's pass in the person. What do we do next? Well, then we can use essentially our method, correct? And if it's not, what options we have? Well, then it's a user, correct? So we go here with person and then login and also invoke it. Again, a very fancy name, type predicate. Effectively, just remember the is keyword and remember the fact that not only we're trying to check for a specific type, but we're also helping Typescript to narrow down that type. Okay, and before we move on to the next topic, I also quickly want to show you one gotcha, and this involves type never. Now, technically, this video is optional. If you're not interested, you can just move on to the next video. But I simply want to showcase that if we hard code the person to be a specific type, TypeScript is going to yell at us. So in here, yes, we are setting up that person randomly, correct? So we have our random person, and pretty much depending on the value, well, we either return a student or a user. Now, if I set up my person differently, let's say if I comment this one out, again, I'm going to go with person. I'll say that this type is actually a person, and then I'll hard code. So I'll say name is equal to Anna, and then since I'm creating a student, I'm going to set up my study method. So I'll come up with my function, and I believe it doesn't return anything. So I'll just go with log and study dot dot dot. Okay, let me fix the typos and all that. So now I have this person, but I'm hard coding. This is not anymore random. Notice TypeScript essentially right away yells at me. It says, well, there's no way this person can be a user, the other type. Why? Well, because you hard coded to be a student. So yeah, I can still check whether the person is student. So type predicate still works, but in the else block, you'll notice that person is never. And this brings me back to the point that I was making in the type never video. Essentially, if you have the scenario where type is equal to never, you'll just have to go back to the initial place where you're setting up the variable and also start checking your conditions. Because effectively in here, TypeScript just says, hey, listen, there's no way that person can be a type user because you hard coded to be a type student. Now, what's interesting, if I change this around to a login, now the person is actually a user, correct? So now I'm hard coding to be a user. So I have my type predicate. I check in my condition. It's not the case. And now we can successfully get to else. But if I hard code my person to be a student, then there's no way for me to get to this else block. Hopefully it's clear. And now we can move on to the next topic. All right. And up next, let's discuss discriminated unions. And also, let's recall how we can set up the exhausting check using type never. Now, again, I know that the name discriminated union most likely sounds pretty scary, but essentially it's just going to be a property which has a literal value. Now, as far as the star code, this is what we have over here. So we have two types. One is going to be increment action. Second one will be decrement action. Both of them take in a number, the amount, timestamp, which is going to be a number. Again, this is totally random. And the same goes for user string. This is totally random. And then we have a type by the name of action, where I use the union type. And I just use both of these types here. So either it's going to be increment or decrement. And then I will set up a reducer function, which is looking for two things. It's looking for the state. So again, this is just going to be some random number, and also the action. So what do we want to do? Do we want to increase the number, or we want to decrease? So let's start setting up, and in a process, you'll see why we need the fancy discriminated unions, which again is just a property with a string value. So for starters, let's go here with new state. And you know what? I haven't set up the function. So maybe let's start with this one. So we have a function looking for state, which will be a number. So some kind of hard-coded number, and then also the action. So whether we want to increase or decrease, and by how much. This is the amount over here. So if we want to increase, then by this amount, and the same goes for decrease. Now, I'm not going to set up again anything as far as the functionality. I simply want to go with reducer. So that's the function. And of course, I forgot to add the name over here. My bad. So we're looking for reducer. Then as far as the initial value, again, we're just hard coding something random. So I'm going to go here with 15. And then when it comes to action, well, now I'm going to pass in the object. So either it's going to be increment or decrement. And in this case, I'm going to hard code that. The user value will be John. We don't have the type yet. So let's just go here with amount of 5. And then timestamp. Well, let's set up 1, 2, 3, 4, 5, 6, or something along those lines. And now let's discuss, why do we need the discriminated unions in the first place? Well, we have two types. And how are we going to check for a specific type? I mean, we cannot use Typeof. We cannot use in. We cannot use, Instanceof, or any of the things that we covered previously. Why? Well, because pretty much they're the same, correct? Now, they do have different meaning. One is going to increase this state over here, and the other one is going to decrease. But in the reducer, how am I going to check for that action? And this is where the discriminated unions come into play, where we'll have this unique literal value. How's that going to look like? We'll navigate back to increment action. And yes, effectively, you'll just add here whatever property name you want. In my case, it's going to be a type, and it's going to be equal to increment. And now we want to do the same thing for decrement. So instead of increment, we want to go with decrement. So now in the reducer, we want to set up a switch statement where we're going to check for the type. If it's increment, then we'll increase. If decrement, then we'll decrease. And also, let's just recap how we can set up our default case with the help of type never. Now, Typescript is complaining because I'm not providing a type over here. So we do need to go with one of them. In this case, I'm just going to go with increment. Again, it doesn't really matter since our main focus is on this logic here in the reducer. So first, let's set up the switch one. And we're going to be looking for action type. That's the property we're interested because it's unique to each type over here. And again, if we have 10 types, yeah, we'll pretty much have to set up the type for all of them and provide that unique value. Then we want to go with case. And in this case, I'm going to go with increment. And as far as what do I want to return from the function, well, let's go with number. So we're going to go with that initial value, basically a state, and we'll add action dot and the amount that I'm passing in. Now we want to do the same thing for the decrement, correct? So let's just change it around. And again, let's just recall the issue with the setup. If we add some other type to this action, well, it's going to fail silently, correct? And therefore, we want to set up the default case, and we want to assign the action to some variable which is type never. Because in that case, if there's some other type over here, it will immediately be assigned to that variable, and we cannot assign to type never. So let's just go over here. Let's say default. That's going to be our default case. Let's also throw, I guess, quite typical scenario. So throw new error, and then I'm going to set up the template string. And in here, essentially, let's set up unexpected. For some reason, this is the biggest challenge as far as the spelling. Unexpected action over here. Type will be equal to never, and we'll assign it to an action. So if actually action is never, if we have handled all the possible cases, we're good to go. But if there's going to be some additional case and we're not handling right away, Typescript is going to yell. And in here, let's just type unexpected action, and then let's access the unexpected action. Again, the point really here is not to run the code. I mean, we're mostly focusing just on the logic over here in the reducer. So this is how we can set up the discriminated unions and exhaustive check using the never type in TypeScript.